I taught myself to do this, but I forgot how to do this.
So this is obviously 1. If you take the 5.386 and divide that by 0.1715, you get
Wait, which one? That's the top one. The
Yeah,
top one you get. The
yeah.
second one you get 8.
you get 8.
Yes.
Good.
So what's the formula? C3 H8 O
Oh.
One.
O.
Oh, one.
Oh.
Oh.
Good.
I see.
Oh.
Now, if you had the time,
You know.
They're swimming together. This is. We're AP. Nobody throws a curveball.
Come on, see it coming.
I'm sorry, you do the cones.
All I can think of is the O's.
What? Oh, that's such an annoying commercial. Okay, here's my prediction about Ozempic, because everybody and their dog is taking this, okay? You mark my words, by the time you all graduate from college, all you're gonna see on commercials is commercials from law firms suing Ozempic because of the side effects that they don't know about yet.
If you've been personally victimized by Ozempic, you may be.
You mark my words.
It's a
You
matter
would-
of loved one who's been affected by mesothelioma. You
I
may
hope
be
I'm
entitled
wrong,
to-
but,
No.
okay.
I need to always look for
Anyway, so here's how you can check that you got this problem right, if you have the time. Find the percentage of each one of those. Find the molar mass of the whole thing. The 3 carbons, 8 hydrogens, and the oxygen. Even if you just did one of them, even if you just take the molar mass of the 3 carbon atoms, divided by the whole thing, that's going to be a certain percentage. Then see if that matches up if you take the 6.18 grams of carbon and divide it by the total mass. If those 2 percentages are the same, you did it right. If they're not, it's a train wreck.
Charles told me to knock down the camera.
I would never.
You have no idea what a fit of rage I would go into. Oh,
How old is that camera?
Is it on?
I don't know.
Is it even running?
Quite a while.
It is running. I can see.
Okay,
We're at 50
now-
minutes right now. 50.
Let's talk about number 7.
7.
What's the difference between empirical formula and molecular formula?
Okay. Sorry. Empirical is the most like simplified. Like
Yeah,
molecular is exact.
empirical is the simplest whole number ratio. It doesn't tell you what the actual structure is, but it's the simplest whole number ratio. So what we're saying on number 7 is the simplest whole number ratio that exists is CHO. We don't know that that's the actual structure, but we know that the empirical formula is CHO. Now, the molar mass of this multiplied by some number equals the molar mass of the molecular, right? So, you need to find the empirical formula of CHO, which is what? Well, you got carbon at
1.
Where are we at right
Is that
now?
what we just were?
Wow.
We're on 12. Okay.
7.
number 7.
What?
Carbon
Okay,
has a
7.
relative atomic mass of, last time I checked,
Oh.
Oh!
I thought you were talking about. Okay.
Good job, Charles.
hydrogen is 1,
Yes.
oxygen is, add all those together, you get
29.
29.
Yes.
So that's technically 29 grams per mole. Okay? So times X, and then they tell you that the molar mass of the actual structure is 174. So, what can you do?
Divide.
And you get,
6.
so the actual formula is,
686.
say 68606. Now, how can you tell that that's right?
You can multiply it.
No, find the molar mass, see if it adds up to 174.
That's what I did.
That's
I
what
just
I would
guessed
do.
and checked because you gave us
They're all
multiple
the
options.
Why would you guess?
Why would you guess it? Well,
Okay.
it only took me one guess because
Now,
I guessed.
let's talk about number 8, which I promise you mark my words right now. On the big test over all of this, you're going to have a problem like number 8. You mark my words, okay?
Your words are marked. They're very marked. We're gonna have a question
They're
just like
gonna-
number 8 on the test.
They'll be in my
overall.
calendar.
Consider
I was
them
paying
highlighted.
attention.
We'll have a question like number 8.
Before or after you threw it?
But before,
It's
during,
too
and
marked.
after.
It's too marked.
So we remember this.
My attention never wavered for a second.
I have to do something like crazy, like remember.
Okay, first off, you have to recognize number 8 as a limiting reactor problem. How do you know that it's a limiting reactor problem? Now, before you do the problem, what do you have to have?
Moles.
No!
A limiting reactor.
You have to have the equation. If you don't know what's happening in the reactions,
So close.
Oh shoot.
Sorry.
What?
We're doing great, guys. We're doing great.
Oh! I forgot oxygen diatomic.
Oh,
Damn it.
Nah, we're good.
Damn it, Bert. I remembered hydrogen. I remembered to do with hydrogen.
We're not done yet.
what do you get out of this?
I think it's
Water.
Water.
Water. Why don't you get hydrogen peroxide?
They don't wanna.
It's not stable. If hydrogen peroxide was the most stable
They
form
don't
of
want us the
hydrogen and
best answer I've
oxide,
heard so far.
hydrogen and oxygen, the oceans would be full of hydrogen peroxide. Got a cut? Hey, go jump in the ocean. You can heal yourself. Okay,
Just drink our hydrogen peroxide.
water's the most stable. What do you need to do to balance it?
2 on the H2 and 2 on the water.
2 on the waters. If you don't have that, you can't do anything else.
Uh-oh.
So that's what
We're good. I'm hanging on still. For dear life.
So, you got 25 grams of hydrogen. What are you going to do with that? Convert it into
Moles. Hydrogen.
moles of hydrogen. Then you're going to convert that into
Moles. Oxygen.
moles of hydrogen into moles of water.
Yes.
Okay?
Is
Yes?
it cool if I just did a rice chart?
Huh?
Is it cool if I just did a rice chart?
You could, but yeah, I don't.
Cool.
Now,
We're good.
then you're going to do the same thing with the 175 grams of oxygen. So you've got, because it's diatomic,
It's 32 grams.
thanks.
You're welcome. No problem.
You wanna make
And
sure
then you're going to go from moles of oxygen into moles of water. Now, you have to be careful on problems like this. Technically, they did not ask how much water was produced. They just want to know what the limiting reactant is. So, out of this, how do you know which one the limiting reactant is going to
Which
be?
one there's less moles of?
The one that produces the smallest amount of water. Okay? That's the easiest way to do the problem. Okay? And I promise you, when you have this big test over acid-base equilibrium and KSP, it's going to be on the last page of the test. I'm even going to tell you what it's going to be. Okay? And it's going to be a problem like this. Right?
So the answer's, what's the answer?
Oxygen.
Okay.
It's
so
B.
I did it wrong like 4 times and still got oxygen.
Good job. That's what I did too.
Magic.
Okay. Anyway.
Why are the waves
Now,
going
when you
opposite
get
directions?
to that last free response question, you're going to do the same thing. You're going to convert them into moles. So this gets a little bit weird because you got 3.4. I know that we're about to run out of time because it's Friday. Mole or 4.58 moles of hydrogen and 3.41 moles of oxygen. So what do you notice about the carbon and the oxygen? They're similar. So whatever the numbers are going to be the same. So if you divide by 3.41, and this one gets a little bit sketchy, out of this you get 1.33. So you can't, that's too far away to round to 1. So 1.33 is the same as
4/3.
1 1/3, which is the same thing as 4/3. So that's the ratio of hydrogen to oxygen. So what's the formula? C3
H4.
O3. There's that answer to the last one. So this took the whole time. So if you need to hand that in tomorrow, you can. If you're done with it, you can hand that in. But if you haven't handed in that lavender sheet from that second titration experiment reaction, I want that. So if you're done, you're done. You don't have any homework.
Yeah, we have lead tonight, so thank you.